So, hello all. We are going to talk today about the project schedule in project management day 3 class. In today's session, actually, we will look into the work breakdown structure and analyze how we can build a schedule based upon the activities and all those dependencies that we have given to us. To understand that work, we have to understand what is actually the work breakdown means. So when the project breakdown means, we are going to talk about an activity here, opening a door. So let's say in this case, if our objective is to open the door, we have to go through several steps in understanding how we can open that door. So some of these activities includes, let's say, call that activity as A, which you are doing the check the pocket. Now you are moving on to the check the bag. Well, your objective is to find the key. Then the activity C, that you are finding the key, you are lining the key with the lock groove and push the key forward into the lock, twist the key with an activity F, turn the knob to right, push the door forward. Well, you may be doing different set of activities to open the door. But the idea here is that to meet an objective, we have to go through a set of activities in particular sequence to meet the end goal. The representation here, each of the square box is represented as an activity and we designate it with a letter A, B or C. So activity A is a task description, activity B a task description. If you come to activity H, push the door, that's an activity description or task description. Now what is this arrow means? The arrow shows the dependency between the tasks. What has to complete to start another one. So this is the relationship between the task and how it has to manage in a sequential fashion so that we can accomplish a goal. It's called task sequencing. So this particular slide is representing how we can represent a task, how exactly we can build a relationship between tasks to meet the final objective. So what are this means WBS? Again, as I mentioned yesterday, work or the earlier video, the work breakdown structure, decomposing of the project into manageable form of task is called task decomposition, and that's represented in a structure diagram is called WBS. Network, those WBS, they don't show in relationship form, it is represented in a network form where you represent the relationship between different activities and show it. Now we'll talk about the schedule next slide, but the fundamental principle here is that how do we represent a task and how do we represent the relationship between the tasks. Now this is a representation of hanging a photo. So in general, without knowing any of the details, you have to start a project and of course you have to end the project. Starting, you could do several things in parallel. You don't need to do all those things one after the other. One activity is that select the location where you want to hang that photo, drill a hole, insert a hook, hang it. You can also frame the picture in parallel. Maybe somebody else is helping you, your cousin, your brother, your spouse, your parent, whoever it is, or somebody is going to get some hardware while you are doing certain things. So idea here is that again task is represented in square boxes and the relationship is also represented by arrows. but it is also showing there are certain activities you can do in parallel. So the takeaway for this slide is activities need not be one after the other all the time. It can be run in parallel as long as they are independent. Let's move on to the little more detail what this all means in a project planning. First thing, we have to understand what is activity. So again, this is a representation of the decomposition of work, or WBS. I know it's not readable. It's not intended to be reading. It is just to show a representation about how we can decompose that work into several work packages, and then work packages can be subdivided. In some cases, it is again subdividing into further levels. Now, activity. Activity is a smallest element or a node element in that WBS hierarchy where you are doing certain things. The guiding principle there is that activity is the one which consumes time and resources. For example, drilling a hole. In that case, you may be using a driller, somebody is drilling the hole, a nail will be done. So those are resources. It consumes some time. 1 minute, 30 seconds does not matter. It consumes time and resources. Also, this is something people are doing to accomplish certain things, and that is leading a progression of project towards completion. Now, the next definition about duration. We understood activity. What is activity duration? Activity duration means you are doing certain things so that activity duration means you are doing certain things so that it is elapsing some time. That is, it is elapsing time. The representation can be done in hours, weeks, and months. Now, next one is parallel activity. Parallel activity means that you can do multiple things at a time. So you are optimizing your time scale as long as you have enough resources. The key word here is that can I do certain things in parallel? Can I do certain things in concurrent way? So now, what this all means in project schedule. When you put all those things together, whether you are running sequential fashion, whether you are running in parallel, when you put all those things together, that will spit out how many hours, how many days, or how many weeks, or how many years it will take to complete a project. That is called project schedule. Now, with the network. The network, as I stated in the previous slide, the task can be represented in different way. There are standard techniques like AOA or AN, does not matter, but how the task is represented defines those things. Now, let's get into some deeper understanding about schedule and networking means. When we look into the previous diagram, like here, there are different ways you could complete hanging the photo. You start from here. This is like path A. Start, frame picture, end. Start, location, drill hole, insert hook, hang. So these are 3 paths I could see. And all these 3 paths, if you put the hours here, let's say this takes 2 hours, 2.5 hours, this half hour, 1/4 of the hour, or whatever it is, you add up that together, it will also take this way. So what this means is that when you look into a critical path activity, you look into what comes to your mind normally. Critical path, it always we think that is the shortest path, that is the optimized path. In fact, that's not true. It is the longest path which takes minimum amount of time necessary to complete the project. Delay of the work in any of the activities in that path will cause a delay of the entire project. So first concept here is about the critical path. Critical path is the longest path which takes minimum amount of time to complete the project. And any delay of the task within that critical path will delay the project duration. Now slack and float. If you look into some of the paths, as in the previous slide, we have 3 paths. One of the paths, if it is not critical, we may have a leeway Slack or float, I think the easier one to understand this concept is float. Float means the task or the job is floating, so it can slide certain way, and that sliding of half an hour or half a day or 1 day or 2 days, if it's not going to delay the entire project, that is called the float or slack of that particular task. Now let's take a look at a little more, I shouldn't say complicated, but a different variety of the network diagram here. So for listeners, we have some numbers for this node. Assume these nodes are tasks or activities. So there are different paths from point 1 to point 12 starting point. So one is like 1, 2, 3, 4, 8, 9, 11, 12. 1, 2, 3, 4, 8, 10, 11, 12. 1, 5, 8, 9, 11, 12. 1, 5, 8, 10, 11, 12. And 1, 6, 7, 10, 11, 12. Those are the possible paths. One possible path is not 1, 6, 7, 10. You cannot go backwards. So it have to go forward based upon the direction of the arrow. So the idea here is that when you look into a project network diagram, you should be able to understand possible path from project start to end. And looking to all the possible path and added up all the duration of the task within that, you will get a project completion duration. And that project completion duration, if you look into that closely, you can evaluate and find out which is the critical path. Which one is the longest path is called the critical path. Now coming to these arrows, when you create a network diagram or when you create a WBS, we also want to see any kind of dependency associated between the tasks. Sometimes if I finish a task and start another one, it is called finish to start. For example, I have to pack my stuff before I go for a trip, or I have to buy the ticket before I go for the trip. I have to get into the car before I drive. So it's like logical dependencies, which means a task has to finish before we starting the another one. That is called finish start. Sometimes both the task has to start at the same time. That is called start start. Sometimes both the task has to finish at the same time. It's called finish finish. This is a little bit complicated one, but I can give an example which will help you to understand the relationship. This is called start to finish. Let's say we are buying a new house, for example. So before I buy a new house, I want to make sure my old house is sold or something like that. Or if I am putting a new system, I want to make sure the old system is returned. So start to finish means that I can only start everything in a newer system if I finish the old one or return the older system. This usually happens whenever we are doing sunsetting of applications or when we are retiring certain applications. This kind of relationship usually happens. 90% of the task dependency in the project management is happening a finish to start kind of relationship. Now, how exactly we can put all these things together in a tool Microsoft project, I will show in a second. But for your understanding from these key slides, there are three main concepts we went through. WBS, breaking down the task into smaller elements. We connect those tasks with the relationships, and based upon the estimation of duration, we say how long the project is going to take. Now, let's say when I do a project, let's say I'm doing a kitchen modeling. It's going to take 45 days based upon my plan. And usual question will say that, okay, how can I do in 30 days? How can I do in 41 days? So that question is posed by a customer or a leadership or within a team member. You have to go through an exercise called schedule compression. There are a couple of ways we could do schedule compression. One is like scope reduction. Remember, what defines the task is that what is the objective of the project. So we are cutting down the requirements, and that way we can save some time. By that we can reduce the schedule. Other option is about crashing, which means that there are critical path activities, and remember the critical path activities is the one which defines how many days is going to take to complete the project. So those activities which actually defines how many days is going to take to complete the project, and you can add more money, you can add more resources, so multiple people can work on it and make this activities more faster. Other option is that in a non-critical path, sometimes we can find out certain things, or even critical path, we can break that activities into smaller portions and see whether those can be run in parallel or not. So anyway, the technique here is that schedule reduction or crashing or fast tracking. Those are the normal techniques that we implement whenever we have a desire to cut down the entire duration for the project. Now, why we build the relationship between tasks? We have seen that different relationships can be built by finish to start, start, finish. Why we are doing it? We are doing it because some tasks there is a mandate relationships, either by regulations. Sometimes the regulations say that you have to do something, you have to get the permit before you do something. Those are mandatory. There is also external dependencies. We have to wait for the supplier to deliver the raw material. There are internal dependencies. Probably we have to wait for some resource to come out of the project. There are discretionaries. Probably we made a decision we are going to do this way because it's going to get more efficiencies. So the bottom line here is that as a project manager, you have to look into the different tasks and understand what kind of dependencies it has, and based on that you build the sequencing, you build the networking diagram accordingly. Now, moving on to the agile world here. In the agile world, what we have seen, we have to write the scope or requirement in user stories. In previous videos, we learned how to write better user stories. Once the user stories is done, there are people, especially a person whose role is called product owner, which defines or writes all the stories, prioritize and say, this is the sequence of stories I want to get it done. And those prioritization discussion is usually happen in sprint planning, or backlog grooming exercise. And then based upon the planning and based upon the implementation, each of the iterations we decide, okay, for 2 weeks how we are going to complete this task, and in next iteration what we are going to bring up, and we complete it. So each of the sprint planning will decide the priority and sequencing so that the project can be completed in a certain interval. And that kind of defines the way of handling the project in different ways. So if you look into a simple example about the agile framework, what you could see here is about, there are a couple of things. One thing is about, if you look into a effort way, you can see it's called, the effort is kind of like burned down. This is called burn down chart. When you start this day 0 to let's say 2 weeks, after probably 2 sprints. 2 sprints means that 4 weeks. That is like a 4th week. What really happens is that effort is going to come down as we are progressing with each iteration. Let's say this is the end of 1 sprint and this is the end of the 2nd sprint. In this case, we can find out how we are doing certain work and how we should able to manipulate that work in this case. So this is actually the end of sprint 1, and this is the end of sprint 2. So in this session, what is also saying is that when we want to develop a product, that product is built in an iteration of 2 weeks. So this is our 2 weeks. We build a product, and that product will have a consumable outcome. And in next 2 weeks, we again plan it out based upon the customer feedback. We build some on top of it, and next 2 weeks we build further, and it keep on building and finish the product. So this is basically a finished product what we can build after every 2 weeks of iterations. Hope you might have enjoyed this session. And in day 3, what we learned today, we talked about the work breakdown structure. We also talk about sequencing of the task, how those tasks can be represented in a network diagram. And finally, we also talked about how that can be split as a schedule. Now let's take a look at how this can be represented in a Microsoft project tool. Tasks one by one, where we created the task, and I also told you at that time every leaf node or unbolded items are called task, and once you completed that entire structure, the tasks column is basically known as WBS. Now today's session we learned about the estimation and duration, where you come to the each of the tasks and type in how much time it's going to take. Let's say for simplicity we use the unit of measure days. So keep on plugging with the days, how many days we are going to take. Let's say 0.5 days, which is like 4 hours you're going to take, 0.5 days. Then here of course we are going to take 1 day, 1 day, 1 day, and then unpack, let's say 0.5 days, errand 0.5 days, click minus 0.25 days, laundry, let's say 0.25 days, and check work 0.5 days, and feedback, let's say 1 day, and video 2 days. So what I have done here is I went through all the task items and plugged in the corresponding values in duration. One thing to note here is about duration. Duration only means if you are working full time on that task, how long it's going to take. For example, let's say you are going to book the hotel and it's going to take you 0.5 days or 4 hours, then you can put that. Remember, you didn't assign any resources here, so assume you are working full time on the task and how long it's going to take if you sit on the task and complete it without having any break. Yes. So now this is done. Now we have to look into the relationship between the task. So here I'm just going to, I'm definitely know packing is the first thing I have to do. Then after packing, can I do hotel booking, car and sightseeing ticket booking? Probably yes. I don't necessarily need to build a relationship between them, but day 1 is only happening when I complete all my preparations. So I could do here is there are 2 ways I could do. One way is that I can put 3 comma I would say here 4. So this means the task 3, which is packing, I have to finish packing. 4 means that I have to do a set of booking. 4 means a grouping of all these events. That is 3 comma 4 means I can only do after that. Then of course day 2 is after 9, then 10, 11, sorry, 11, 12. That means of course day 2 can only be done after day 1, which is 9. So remember, these numbers means the task IDs. So day 3 can only be done after 10, which is day 2. So it's a sequential way is happening. If you look into the right side of here, you will also see some sequential visual representation of how the task is aligned up. Now coming to the unpacking, let's come here and say, okay, I have to finish my vacation. So I can do task 8 and then run errands. Of course, can I do same? Probably not, because I'm the one who have to do it. So I have to say 15, and then I will say get the mail 16, and then laundry I can do 17, and then 18, and then I could do only after, let's say after the 19 is done, and then the 20. So this kind of so then the next task is about putting in the video. I have to do it after 21. Let's say it's 21. Check this number is correct here. That is correct. So again, a visual representation will show us how the task is interlinked and how it is connected. So once I have completed this one, I basically develop a schedule. To make it more clear what I have to do, I put the duration, I put the predecessor, and I have all the tasks. I can do a quick way of highlighting all the tasks by clicking on this corner and auto schedule everything, which will shift the task left and right and make sure everything is properly aligned. The last thing I have to do to make it as a good project schedule, I have to say what is my project start date. Let's say I'm going to plan for vacation 21st, or let's say 21st, because this is something you have to remember. The calendar here is Monday through Friday and weekends are off. So even though this is a fun project, since we are not changing the calendar, we have to assume we are working on weekdays. I'll show you a method a little bit later how to change the working days and calendar, but as of now, assume everything I am only doing on weekdays. So if you want to say, if you want to go in that particular week, one other option you could do, I am doing all the booking. Let's say this is my week of vacation. I can start doing, let's say somewhere here on 17, for example. Let's say what is going to happen. So that means I could do 21st. I will do everything here on the previous week, and then my vacation starts here too. That's the best way of doing it. And you can also save it or save as. So this is basically vacation BPS, or this is basically the schedule portion. So now I have created a project schedule, which you can see it here thoroughly. And this, when I look into the summary of the project information statistics, I can say it's going to, the overall planning and wrapping up is going to take 12 days, and the cost is 0, which I'll show in the upcoming videos how to put the cost. At least by this setup, we have completed the project schedule. So with this video, my objective is to let you know how to create WBS, decomposing the task with the project objectives into smaller chunk, which is a manageable piece, how to do some estimation the duration, how to put some relationship based upon the task dependencies, and then do some shifting around of tasks and put a project start date, which will spit out project schedule. So now you are a official project manager where you can build a project schedule. We will worry about the cost a little bit later in the video. Now you are good with the schedule. Now one more thing I have to show you. When I double click on the task, it will show you some advanced technique. It will tell me exactly here how the relationship is built. Let's take a task like here, and look into the predecessor, you can see, okay, this is the packing, and I do have some relationship between the task which is finished to start. This is the opportunity you should be able to change the relationship. For example, let me show one a quick example to help you understand that. Let's say these two tasks. Okay, this one, if I say video, I am doing video after the feedback. I'm doing video after the feedback. That's what finish to start is happening. Let's say if I change that to start, I'm doing both at the same time. Look at this graphical change happen. It started at the same time. So that's the way you could do certain optimization, and that will change the, let's say, what really happened there in that. This is like 1 1 I am changing. When I make those things as parallel, what really happened is that saved me a day, and my project ending date got changed. So this is the way to find out how to optimize the task by changing the relationships. So in summary, let me wrap up today's session. And today we learned about WBS, decomposing the project into smaller chunk of activities, and each small chunk we do estimations, and that will give us the duration. We also build the relationship between tasks, which is by networking or sequencing within the Microsoft project tool. We build the predecessor relationship. Once you do that, we can also make sure you build all the activities and hit the auto schedule with the project start date. That will easily spit out a project schedule. We also learned about the critical path. So let's take a look at that. In this project, what are the critical path items? One way of looking at it, when you look into view critical, you can say these are the highlighted yellow ones are critical activities. According to your definition, remember, if I say instead of taking 2 days, I took 3 days, any delay in the activities in the critical path is going to change. For example, like the laundry that you're doing, if you are going to take instead of 0.5 days, if you take like half day, if you take 1 day, so any activities in the critical path, if you are going to change, if you are going to delay, that's going to delay the completion date for the project. So this is one way of seeing the highlight. If somebody asks, okay, this is the project schedule, give me the critical path, the tool will get you all the critical path. There is also a different way, which I will explain a little bit later. There are a lot of reports that you can generate from the tool. From the report itself also, you should be able to tell you, give me all the activities in this project, which is critical path. In this sample project here, it is simple because we have only 22 tasks. In case of a real life project, it could be 100, 200, 300 line items. It's very difficult to find that out. That's what we use normally the report to identify the critical path. Hope you enjoyed the session and you got a strong understanding about work breakdown structure, critical path, and the project schedule. And hopefully you can utilize your learning in your project management skill application, and wish you good luck with more learnings and application of project management, and enjoy project management career. Thank you.